Finding points on a segment in the XY plane. If we're given two endpoints of a segment, we know how to find the midpoint. And I have an example up here that we're going to go through in a second. But just a recap on how we find a midpoint between two endpoints on the XY plane. We're going to look at the x values of each one, and we're going to average those out. So we sum those two values, divide by 2. We're going to do the same thing with the y coordinates of those endpoints. And after we compute these calculations, we will get a point right in the middle of those two endpoint values. Now, what if we want to find a point anywhere else along that segment? So here we have an example where point P is 2/5 of the way from M to N. We want to find the coordinates for P. So here's an example of a problem where now we're looking at for a point, not necessarily right in the middle, but some fraction of the way from one endpoint to the other. Now, it is going to be important that you identify what direction you're traveling. So before we even start our calculations, it's worth noting where's our starting point, where's our ending point. If 2/5 of the way from M to N, we know M is the start, and we know N is the ending point. Okay, so we'll just take note of that. Now, anytime we have problems in our coordinate grid, it's always helpful to plot these points to get an idea of where they're located and ultimately ballpark where we think our point should be that we're trying to find. So -2, there's our M. And then we have 8, 3 for N. Now we want to go 2/5 of the way. So somewhere in this region, we should expect to find our result. Now, how are we going to get this? So there's no set formula that we need to use. So we need to think about, well, what are we able to calculate given this information right now? Well, what we can do is find the horizontal distance it takes to travel from M to N, and then also the vertical distance. And we can do that through calculations of our given coordinates, or we can just count off the distance traveled on our coordinate grid. So I'll show you both ways, but counting, we can see that the horizontal distance traveled, we're going to go 10 units. And then the vertical distance traveled, we're going 5 units. The algebraic way to calculate that is horizontal distance traveled. We're going to find by just doing the change in the x coordinates. So distance between the x values. How do you find the distance between two x values on the coordinate grid? We're going to find the change in those values. And if we want to avoid coming up with negative numbers because we're calculating distance, and we don't want to necessarily take into account or have to think about the order in which one's subtracted from the other to ensure that we get a positive value, you can just toss on some absolute values to take care of that issue. So what we're going to do, looking at M and N, I can label these as x1, y1, x2, y2, and again, that absolute value, once we introduce that, we don't have to worry about which one comes first. We can do 8 minus -2 or -2 minus 8. We'll get the same thing because we get absolute value of -10, which is 10. So there's the algebraic way to calculate that. A good thing to know, especially when our coordinates get a little messier, they're not necessarily nice, clean numbers, and it may be difficult to count off. Or if they're really large numbers and we don't have a coordinate grid that would accommodate them, and it would be a pain to actually draw one. So we're dealing with some nice small numbers here, but knowing how to do it algebraically is useful, again, in the event that you're dealing with very large numbers where it's difficult to actually have a coordinate grid to accommodate that, and drawing it by hand can get a little sloppy. And if we have some crazy decimals maybe involved, it's always good to know the algebra. So we have horizontal distance traveled. Now vertical distance traveled, we're going to calculate that as well. The axis that runs vertically is the y-axis, so vertical movement is going to be dictated by our y-coordinates. So we're just going to do absolute value of the change in the y-coordinates. And again, the absolute value is thrown on there, so we don't have to worry about order. So we're going to do -2 minus 3, absolute value of -5, which is 5. So the algebra matches our counting method, but we just calculated the total horizontal distance and total vertical distance traveled to get from M to N. And you might ask, well, why didn't we just count off the diagonal distance and find 2/5 of that? Well, we can't count off diagonally, right? So at this point, we found total distance. We are going to find 2/5 of those distances. So we then take this fraction that's given to us, or what portion of the way we want to go from one point to another, and we multiply these total distances by that to tell us how far we need to go from the starting point to get to this point P. So let's add in to get to P. So horizontally, we're going to take that total distance traveled and we're going to multiply it by the portion of the way, or the fraction of the distance we actually want to go. So this, we're going to get 20/5, which is 4. And then for the vertical, we're going to take total, multiply it by how far we want to go along the line. We're going to get 10/5, which is 2. Now, at this point, don't make the error that this is the coordinate for P, 4, 2. That just tells you how far you need to travel from M to get to P. So we still don't know the coordinate, but we can go count this off. So I'm traveling horizontally 4 units and vertically up 2 units to get to point P. I can go to my point M. This is why it's important to know where you're starting. So start, N, because 2/5 of the way from M to N is different from N to M. And we'll take a look at that in a second. But going from M to N, I know I have to go 4 units horizontally and then 2 units vertically. And if I plot that point there, it does indeed look like that point is about 2/5 of the way from M to N. And I can see that it does fall on the segment MN. So I need a point that also actually falls on the line, another super important detail that you want to pay attention to if you're going to check your work using a drawing. So yes, it does look like it covers the fraction that's desired, and also it does fall on the coordinate. So to answer the final question, what is that point? We can see that that's 2, 0, but to mathematically verify that our point is 2, 0, we can go back to point M, our starting point, so M was -2, -2. And we know from M, we have to go 4 units to the right and 2 units up. If I want to move left or right, that is a horizontal movement, and therefore I'm going to alter my X coordinate. And if I want to move up or down, vertical movement, I'm going to alter my Y coordinate. So to get to P, we said to move right, we should add. So I'm going to add 4 to that, and then to move up, I should add. Oh, sorry, it was only 2 units up. And we do indeed get the same point that we got from counting, verified through algebra. So there's an example there. Now, just to show you that if we were to go from N to M 2/5 of the way, we still know that we only need to go 2 units vertically and 4 units horizontally. We end up at this point, which would be 4, 1, 2 different answers. So that's why it's important to be able to identify starting and ending points to start the problem. Let's do one more, and then we'll summarize at the end. So our second example and our last example, we can move a little quicker through this one, but we have point Q is 1/3 of the way from S to R. So we're starting at S and moving towards R. Let's plot our points. I'll do it in a different color. Once we plot our points, we're going to calculate horizontal and vertical distance traveled in total to get from S to R. So we can count. In this case, we're going to see that horizontal distance traveled is going to be 6 units and vertical distance traveled is going to be 4 units. To verify algebraically, let's do horizontal. To get horizontal algebraically, we're going to do absolute value of the change in the x values. So 7 minus 1, absolute value of 6 is 6. That does check out. Vertical distance traveled, we're going to do the change in the y values and take the absolute value of that. So we can do 0 minus 4. So we're going to get absolute value of -4, which is 4. So that checks out. Now remember, this is total distances traveled to get from one endpoint to the other. We only want to go a third of the way. So we're going to take our horizontal distance of 6 and we're going to multiply it by 1/3. And we're going to get 6/3, which is 2. And then we're going to do the same thing for our vertical distance. We're going to multiply it by 1/3. And we're going to get 4/3, which we can keep it as 4/3 if you'd like. Or we can change that to a rough approximation of 1 1/3 or 1.33. Then I take a look at S and I consider movement. So in order to get to R, I must move left and then up. So then if I look at my coordinate S, which is my starting point, so S was at 7, 0. To get to R, I have to move left. And to move left 2 units, to show that algebraically, we must subtract the value from the x-coordinate. So to get to this point Q, again, moving left, so we got to subtract 2. And then to move up, we're going to add to the y. So I got to add 1.33 to the y. 0 plus 1.33, or 0 plus 4/3, whatever you want to work with. Then we can clean this up. So Q is going to be at 5, and then 1 1/3. So let's go over to our coordinate plane and see if we can plot Q. So 5 and then 1 1/3 is roughly right there. To me, that does look like it's a third of the way from S to R. And again, that point did fall on the line that connects those two endpoints. It falls right on the segment, super important. So yes, we should feel confident about our answer. We confirm that algebraically there. And even counting from S to left up 1.33, we fall in the same place. So it all checks out. And that is how you find any point given some fraction of the way from one endpoint to another in our coordinate plane. So let's recap the process. The first thing is identify starting and ending points. The second thing, after you know where you're starting and ending, which is ultimately going to dictate direction of travel, which we'll talk about at the end, after that we want to find horizontal and vertical distances traveled to get from one endpoint to another. So calculate, we'll say total horizontal and vertical distance from one endpoint to the other. You can do that by counting in some cases, or through algebra, change in x for horizontal and change in y for vertical. Once we've done that, we're going to find, or we're going to apply that fraction that's given to us to these distances. When I say apply, I mean we're going to multiply. to the total distances. Okay, the result of that is going to tell you, so the result of this step tells you how far to move from the starting point. So again, after this part of the process, this is not the coordinate that you're looking for. It just tells you how far to go. Once you've done that, you should identify the direction you need to travel to get from one point to another. So you know how far you have to go. Now identify direction. And the reason that's going to become important is because if we're going to confirm this algebraically, for horizontal, if we're moving right, you're going to add to x the value from step 3. And if you're moving left, you need to subtract whatever value you found in step 3. And then for vertical, if we're moving up, we're going to add to y. And then down, we're going to subtract from y. What value are we subtracting? Whatever value you found when taking the portion of the total in step 3. So once you identify direction, identify direction and then apply distances to the coordinate. And how you apply it, again, is written down below. Once you've done it, a good way to check your answer, eyeball that it's actually roughly the fraction of the way from one point to another that you're desired. So eyeball distance. But also, the other thing is make sure the point actually falls on the segment, right? Super important. We're trying to find points along a segment. So if the point you found isn't even on the segment, something went wrong. So a couple examples in that video, a summary at the end, and that's how you find points at any point along a given segment when you have coordinates for the endpoints and some fraction of the way to go.